Today we are going to discuss basic arithmetic operations. There are 4 of these which we will talk about: addition, subtraction, multiplication and division. When we think about arithmetic operations, we often assume they will be linked to tricky numerical calculations. I'm hoping to show you a different side of numbers and maths itself in this chapter. I will try to help you understand the structure of numbers, which should make the calculations much easier. To begin with, we will focus on addition and subtraction. If you are good at adding and subtracting, you will find it much easier to learn the rest of the maths at this level. There are some really quick methods for adding and subtracting so that you don't have to waste too much time thinking about it. We will also cover negative numbers in practical contexts, such as finding out how much hotter or colder one place is than another. For some questions you will not be able to use a calculator, but for others you will. When using a calculator, it helps to estimate your answer first. This way, if you press an incorrect button and the answer is way off, you should realise and carry out your calculation again. In this section, we are going to look at working out sums in your head. We can use partitioning to help with this. This involves splitting each number into tens and units. Here is an example of addition: 32 plus 46. If we first split each number into tens and units, it should look something like this. We can add the tens first. 30 plus 40 equals 70. Then add the units. 2 plus 6 equals 8. Then add these two together. 70 plus 8 equals 78. Here is an example of subtraction: 56 minus 34. We can deduct the tens first. 50 minus 30 equals 20. Then deduct the units. 6 minus 4 equals 2. Then add these two together. 20 plus 2 equals 22. A number line is another useful tool for solving addition and subtraction questions. Work out 145 minus 68. Here we can use a number line to find the root between 68 and 145. If we count from 68 to 70, this leaves the number 2. We then count from 70 to 100, which leaves 30. From 100 to 145, this leaves 45, and therefore we need to add 2 plus 30 plus 45. This equals 77. A number line can be extended infinitely in any direction and is usually represented horizontally. Now we are going to look at column addition and subtraction for those larger numbers. If the numbers are too high or too difficult to add or subtract in your head, we can write them down in columns. It is important to first separate the numbers into ones, tens, hundreds and thousands, etc. Let's look at the example 2367 plus 452 plus 85. We must always add up the units column first. So 7 plus 2 plus 5 equals 14. Because our answer has gone from 1 digit to 2, we take the unit, which is 4, and write this in the answer underneath the column of units. We can then carry 1 over to the tens column. Now add up the tens column, so 6 plus 5 plus 8, which equals 19. Before we put the answer in, we must add the leftover unit of 1 to the total, so this makes 20. So we now put the 0 in the answer under the tens column and carry the 2 over to the hundreds. Next we add up the hundreds column. 3 plus 4 equals 7. 7 added to our leftover 2 equals 9, and therefore we put this answer in. The next column has one number, which is 2, and there is nothing else carried forward. Therefore, we place 2 in the answer. The total answer is now 2,904. Now that we have tried column addition, we will now look at column subtraction. This is an efficient method, but you must have an awareness of place value. Let's work out 72 minus 56. First we line up our units and tens columns, then we subtract the units column. 6 is greater than 2, and in order to deduct 6 from 2, we must borrow 1 from the tens. We therefore cross out 7 and change it to 6 and transfer the 1 over. Now we deduct 6 from 12, which equals 6. This is written into the answer column. Next we deduct 5 from 6, which equals 1. Therefore our answer is 16. Now that we have covered adding and subtracting whole numbers, we will move on to decimals. When you use a column method for adding or subtracting with decimals, it is important that you line up all the decimal points under each other. We're going to have a look at an example on the next page. Here is an example. James has a piece of wood which is 1.253 metres long. He cuts a piece which is 0.752 metres long and it is to place on a windowsill. How much wood does he have left? First find the sum you need to answer. So that's 1.253 metres minus 0.752. Now write it in column format. Now we are going to carry out the calculation which is very similar to the one previously. Beginning with the thousands column, 3 minus 2 equals 1. 5 minus 5 equals 0. For 2 minus 7, we must take 1 from the units column, making our calculation 12 minus 7. This equals 5. Then 0 minus 0 equals 0. So our answer is 0.501. When you add or subtract decimals, make sure you line up the columns correctly. The decimal points in the numbers you are working with and the answer should be underneath each other with the numbers matching each place value. This includes zeros. With problems, you will need to decide whether the amounts involved should be added or subtracted. Here are some examples of the words you should look for. Okay, so we do cover negative numbers in a previous video, but we are going to just briefly cover it also in this one. We want you to be able to use negative numbers in practical circumstances. You will need to add to them or subtract from them. Negative numbers are numbers less than 0. Negative numbers have many uses in everyday life, for example, to show money withdrawn from a bank account, or temperatures below 0, and to show height above sea level on maps. A number line is a very useful tool when working with negative numbers. If you look at the number line, you will notice that the further to the left a number is, the smaller it is. For example, minus 2, we say negative 2 or minus 2, and this is smaller than 1. Negative numbers are often used when talking about temperature. For example, on a cold winter's day, the weather forecast might give the temperature as below freezing, or minus 2. The temperature of a freezer would also be a negative number. Negative numbers can also be used to talk about money. Think of the amount of money you have in your bank account. If you go into minus numbers, this means you owe money. So minus 2 means you owe £2. Let's look at how we can use a number line to add and subtract using negative numbers. First, draw a number line and find your starting point, which is 0. Next, you need to count 6 to the right. Here is how you would add 3, and finally here is how you would subtract 6. Having a picture in your head of a number line above and below 0 is really useful for this type of question. You can imagine bouncing along it as you add or subtract. Here is a practical scenario which uses negative numbers. The temperature at 6 p.m. is 1 degree. By 4 a.m. the next day it has fallen 4 degrees. What is the temperature? We must begin by drawing our number line and counting down from 1 degrees. Our answer is -3 degrees. Here is another example. Leon's bank account is overdrawn by £55. He withdraws £10 from his account. By how much is Leon overdrawn when the £10 is taken from his account? The bank account is already £55 overdrawn, which means there is -£55 in Leon's bank account. If he withdraws another £10, then the account will be overdrawn by £55 plus £10. This equals -£65. Leon is overdrawn by £65. We are now moving on to multiplication and division. Multiplication and division are closely related. Division is the inverse operation of multiplication. When we divide, we look to separate into equal groups, while multiplication involves joining equal groups. We are going to also be learning long multiplication and division towards the end of the chapter. These are skills which you will hopefully find useful as you move on to further topics. Here we are going to look at some basic calculations. For question A, we have 52 multiplied by 4. To begin, we must first multiply the units by 4 and then the tens by 4. 2 times 4 equals 8 and 5 times 4 equals 20. (93) divided by 3. First divide the tens and then the units by 3. 9 divided by 3 equals 3. And 3 divided by 3 equals 1. 16 multiplied by 8. So 6 times 8 equals 48. You write the 8 in the units column and carry 4 tens over. 1 times 8 equals 8, so add 8 to the remainder of 4, which is 12. 100 is carried over. If you look at the multiplication grid, you will see a diagonal line that gives you the answers to 1 times 1, 2 times 2, and 3 times 3, etc. These are the square numbers, so 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These numbers are worth remembering. There are also numbers which are classed as multiples. An example would be the numbers in the 5 times table, so they are 5, 10, 15, 20, etc. So these numbers are called multiples of 5. And lastly, there are factors. So a number that will divide into another number exactly is called a factor of the number. So for example, 2 is a factor of 8. If you multiply something by 10, you will need to move the units into the tens column, the tens into the hundreds column, and so on. Here are some examples. If you multiply something by 100, you move the units into the hundreds column, the tens into the thousands column, and so on. Here are some examples. Dividing is the reverse of multiplying. So to divide by 10, you move the digits one place to the right and take a 0 off. This only works if the number ends in 0 though. Here are some examples. To divide by 100, you move the digits 2 places to the right and take the 2 zeros off. This will work if the number ends in 00. Here are some examples. You can use place value tables to help you multiply and divide decimals by 10 and 100. Let's use a worked example to see how to do this. So 25.7 multiplied by 10. To multiply by 10, you move each digit one place to the left. So 25.7 multiplied by 10 equals 257. Let's look at 346.1 divided by 10. To divide by 10, you move each digit one place to the right. So 346.1 divided by 10 equals 34.61. And now let's just have a look at 46.1 divided by 100. So to divide by 100, you move each digit 2 places to the right. You usually write a 0 when there are no digits in front of the decimal point. This makes the number easier to read. Sometimes you may have to multiply a whole number and a decimal. Let's look at the following example. Alberto wants to purchase 4 ice creams costing £2.20 each. How much will he pay in total? There are 2 ways of doing this. We can either work in pence or pounds. I will show you both methods. So working in pence, your calculation should look like this. First you multiply the units, 0 times 3 equals 0. Then the tens, 2 times 3 equals 6. Then the hundreds, 2 times 3 equals 6. Your answer is 660, which can then be converted into £6.60. Now we will work in pounds. Make sure you line your work up carefully by placing the decimal points in line underneath one another. So 0 multiplied by 3 equals 0, and 2 multiplied by 3 equals 6, and finally 2 multiplied by 3 equals 6. Here we explain the basic steps for long multiplication. Let's look at the following sum. First we need to put the digits into columns and line them up. The 5 and 1 are aligned in the units column and the 4 and 2 are aligned in the tenths column. We will start by multiplying the number at the bottom with the 1 at the top. We always begin by multiplying the units. So 1 multiplied by 5 equals 5. We will then multiply 1 by the digit in the tens column. So 1 multiplied by 4 equals 4. We have now multiplied the units digit of the bottom number with each of the digits of the top number. We can strike out this digit. We will now move on to the next digit for the bottom number, which is in the tens column. Because the tens digit always has a units digit next to it, we will need to add a 0 to the units column. So 2 multiplied by 5 equals 10. So 0 is written in the tens column and 1 is carried over to the hundreds column. Our next calculation is 2 multiplied by 4, which equals 8. We then add 8 to our remaining 1, which is carried over. This equals 9, which is placed in the hundreds column. The final step is to add both answer columns together, which gives us our answer, 945. When multiplying decimals, add up the number of digits after the decimal points in the question. This number tells you the number of decimal places you should have in your answer. So if the question includes 1 decimal place in total, 4.2 multiplied by 6, then the answer must include 1 decimal place, 25.2. If the question has 2 decimal places in total, 5.3 multiplied by 3.2, then the answer must have 2 decimal places, 16.96. It helps with long division to understand all of the parts that make up the calculation. First, we will look at an equation that doesn't have any remainders. 46 divided by 2. How many times does 2 go into 4? The answer is 2, and this is written above the 4. Next, we work out how many times 2 goes into 6. The answer is 3, and this is written above. Our answer therefore is 23. Once you are confident dividing in the basic format, we can then move on to division with remainders. In mathematics, the remainder is the amount left over when the first number does not divide exactly by the other. For example, say you have a 200 cm length of wood. How many lengths of 60 cm can be cut off from this length? When you do 200 divided by 60, you get 3 whole 60 centimetre lengths, which measures 180 centimetres in total, and so you have a remainder of 20 centimetres left. Let's look at the following example. 57 divided by 5. We begin with the tens column and 5 goes into 5 once. Therefore, we write 1 in the answer above. Next, we need to work with the units column, which is 7. If we try to work out how many times 5 goes into 7, we know that it will go once, but there will be a remainder. The remainder is 2, and therefore your answer will look like this: 11 remainder 2. Now let's look at a slightly more complicated calculation which we will carry out long division for. 762 divided by 3. The steps you must remember when carrying out long division are: the first step is to see how many times 3 will go into 7. So 7 divided by 3 equals 2 remainder 1. We write the 2 above the 7 and we will see the remainder 1 later on. Next we multiply 2 by 3. So 2 times 3 equals 6. The answer 6 is placed below the 7. Now we subtract the 6 from the 7, so 7 minus 6 equals 1. 1 is our remainder. As you can see above, we have gone through the process of dividing, multiplying and subtracting the first digit of our dividend. We now go through that process with the next digit of 6, but first we must bring the 6 down so that it is in line with our first answer of 1. This now makes the digit 16. 16 divided by 3 equals 5 remainder 1. Ignore the remainder for now and answer with 5. 5 multiplied by 3 equals 15. Write 15 directly beneath the 16. 16 minus 15 equals 1. Now you subtract and the answer is 1. Next, bring down the 2, making your latest answer 12. And 12 divided by 3 equals 4. Write your answer at the top. 4 multiplied by 3 equals 12, so write 12 beneath your answer. 12 minus 12 equals 0, so you are left with no remainders. Your answer is 254.